I'm redoing my 3D dungeon crawler in Godot video because the audio was pretty bad in the last version, and I'm actually going to turn this into a series, so we will go through quite a bit more than that previous video did. And I hope this video is helpful to everyone. So what this first video is going to cover is basically what was covered in my original first video. We're going to build up the world using a mesh library and a grid map. Then we're going to build the player using grid-based movement, and we're going to learn how to detect walls so that we don't pass through walls. And then we're going to build a UI using a sub viewport, and we'll add navigation buttons and a compass. So that's the plan for today. This video series assumes you're somewhat familiar with coding in GDScript, and you are familiar with Godot generally. I will be walking through everything, but some things might go a little bit fast if you're not already familiar with those topics. So feel free to follow along, but if this moves a little bit too fast, you might want to do a little more background stuff with coding and with Godot, and then come back to this series. But feel free to leave any comments or questions you have in the comments for this video, and I will try my best to answer them. In future videos, we'll be going over how to make some low poly assets, so things like, swords and axes, and maybe even some character models for enemies. We'll learn how to interact with the world, so being able to click on things like buttons and items. We'll learn about combat, we'll learn about item management, so like inventory and also using items. And then we'll also go over some RPG elements, like how to actually build our characters. So with that out of the way, let's get started. So here I am in Godot, and the first plan, or the first part of the plan, as I said, was to build up just our asset library and the world. So I'm going to do this a little bit differently than I've done before. I'm going to just make, I'm going to use just a plane for the floor and then just one box for our individual grid elements, and then I'll do another plane for the ceiling. So that'll make it a little bit easier to manage everything. So the first thing I'm going to do, I'm just going to build up our asset library, which is literally just going to be one mesh. So I'm going to add a node to our 3D scene, and that's just going to be a mesh instance 3D. Create, and we're going to make this a box mesh. So we can just, whoops, not multi-mesh, what's going on here? Going up to add mesh instance, not multi-mesh instance. Okay, mesh. And we just do a box mesh. And for this, I'm going to have it be 3 units tall, or 3 units wide by 2 units tall. So you can see it's not a square, it's sort of a rectangular prism. And I'm just going to save this. I'm going to save this as, let's see, we can just do a mesh instance 3D, that's fine. Well, actually, I'll do brick wall. Save. Say this is a brick wall. Okay. Now, so what I'm going to do is come over to this website called Polyhaven. And Polyhaven has lots of free assets for you. So things like meshes and HDRIs and models. And all I'm going to do is grab a few assets for textures. So what I'm going to do is download a couple textures. Now I'm basing this off of the original Eye of the Beholder game. So I'll use a green sort of base, like a green mossy base. So that one that was shown, this rocky terrain, I kind of like that. So I'm going to grab this, and what I'll show you how to do is not just how to use the image itself, but also some of these other images in the mesh, or in the asset. So we're going to get the ambient occlusion, and I'll just get the JPEG. So we'll do save, and then I've already grabbed a few of these. So I'll just save this rocky terrain. And then we want our diffuse, or we're going to get the displacement. Do the normal, let's see, I think it's the normal GL we want. Oh, and we do want the diffuse. This is like the actual image. So I've already grabbed it. Just save that. And then, let's see. That might be enough for now. Okay, and then since we're doing the brick wall, we also want to get a good brick texture. So if we go up here to, instead of aerial, we go to brick, you can pick out a good brick. I think I did this medieval red brick, but you can do whichever one you want and get those other materials that we grabbed already. So I am going to open up my downloads. Where did I save them? Okay, so I'm going to create a new folder and call this materials. And then I'm going to take oh, and I think I want the displacement too. So I'm just going to grab all the stuff that I've already grabbed. And I need to get the displacement as well. Go into this, grab the displacement. Did I get that already? Yeah, displacement. Displacement. Oh, that's what it was. Okay. Let's just double check. So I should have 8 images in here. Let's see. Oh, I need the roughness too. Okay. Oops. Let's see. Roughness. Okay. Drag that in. Okay, so now we've got these 5 different images. And what we can do is minimize this and go to Surface Material Override, New Standard Material. And then let's save this as in our brick. We'll call this brick material. So, so these names don't line up exactly perfectly with what we have, but basically the albedo, this is the color, so this is where we want to put the diffuse. So we drag this into this texture, and sometimes it can be a little bit slow, but if I drag it in and let go, now we can see that we've got the diffuse there. And actually, I don't want to use the grass, I want to use our brick. So so I've downloaded this brick as well. So I'm gonna drag the brick in here. We can also open it by using that. Okay, so now we've got the brick in here. That looks nice. But then there's a few other things that can make this look good without really adding a whole bunch of texture and polygons, or without adding a bunch of like mesh and polygons. So if we go to our normal map, we can say turn this on. We'll open. And we'll do the worn brick. I think it's that one. Is that right? Yeah. then, let's see, is that right? Yeah, worn brick floor normal. Okay. And then ambient occlusion, we can turn this on. We'll open, open worn brick, or it's that one. Oh, that's displacement. That right? It's the roughness. Wish I could see the full names. That one. Worn brick floor ambient occlusion. There we go. And then, so for displacement, what we want is actually height. And this we can say is just like 0.5. This gives like a little bit of extra like depth. And I think it's this one. Oh, that's roughness. Terrain. Yeah, displacement. Then our UV, we can make this smaller if we want to, so like 0.5, and that'll make it bigger, or 5 to make it like really small. I think we might want to do like 2. That kind of looks pretty nice. And it's kind of hard to tell that changing all these other things did much. Oh, we need to also add the roughness. Yeah, roughness. That's this one. Nope, that's ambient occlusion. That one. That's normal. Just make sure so it's brick floor. Floor. Oh, that's wrong. That it's at the height. That's displacement. Good. And then displacement. Okay. Oh wait, no, roughness. Yeah, there we go. Okay. So now when we look at this, that'll do things with like the lighting and everything and make it look pretty nice. So we're not going to worry about the top too much. We're going to mostly be looking at this from the sides. But now we have a brick wall. So then we want to, now we're going to use a grid map. So a grid map is like a tile map, but for 3D. So I'm going to add, let's see, add a grid map. Actually, I don't need the grid map. What I need is, we'll make this scene. I'm just going to make a scene, and I'll just say this is our playground. I use playground as just like a general purpose, like test out the tools that we have and test everything that we have. So now I'm going to in here add our grid map. And in our grid map, we need a mesh library. So we need to create a new mesh library. And what we need to do is in our grid map, let's see, we need I think we can actually take this brick wall scene. We can see, say, go export as mesh library. So then we can call this our brick wall. Or let's see, we'll go grid mesh library. So we'll just save that. Now if we go in here, load grid mesh library, clear. Seeing it. So do 3 and 3, 2. Maybe we need to add a there we go. Okay, so now we just needed a node 3D, so we'll just say mesh light. Doesn't really matter. Okay, one more thing we can do for this is we need each mesh in our mesh library to be the root of whatever it is we add to that. But then we can also add a child node of a static body to 3D. And then this needs a shape. So what I'm going to do is go here and go mesh and create collision shape. And I'm just going to do bounding box, so that'll match the size of it. And then I'm just going to bring that up there. And so now we can see we've got our bounding box that perfectly matches the mesh. So then if I, from here, if I go scene, export as mesh library, not merge with existing, I'll just save it as that. Then go into our playground. Now I grab my paintbrush, I'll be able to paint walls wherever I want them. So before I do that though, I'm going to do I'm just going to add a mesh instance 3D. We don't actually need this to be a static body because we're not going to be using it for physics or collisions or anything. So what I will do is I will just grab a new plane mesh. I'll make this not huge, but I'll make it 32 by 32. And here we'll make our other material. So I will minimize that, and I'll do our surface material override, nude standard material, and I'll save this as our rocky terrain. And again, we're going to use these images, the ones that I just grabbed. So we're going to do the diffusion as the albedo. And then roughness, I can actually see it over here, which is nice. So there's the rocky terrain rough. And then our normal map, we'll turn that on. Go rocky terrain normal. Whatever reason, I think it's just because I haven't loaded it yet. It'll take a second to actually put it in there. And ambient occlusion. There's the rocky terrain AO. And then let's see, detail, no, height. Height is on. I just go 5, sure. Do the displacement, that there. Okay. So now it should look kind of cool. It'll, again, lighting will impact this and whatever. All right, now we'll do our brick wall, and this is pretty big. All right, so matter. Okay, so for whatever reason, the icon is like 1 by 1, and this is 3 by 2, but that's fine. Just erase those, not that it matters too much. We could have made it one bigger, doesn't really matter. But now we have a starting point for our world. Now, if we wanted this grass to repeat a little bit more, we could go into here and make this like 10 or 3, and then it would like be a little bit smaller. I kind of like it like that. I don't know, maybe I'll do 2. So now it'll sort of tile that image, and it'll be different, but it won't be massive. So that looks pretty good to me. One other thing we always need for our main view, we need to be sure we add in our world environment, and I'll add in a sun. I don't think the sun will make too much of a difference, but we're going to add a light to our player anyway, so it won't really matter. Directional light. I just like to move this up and out of the way. Okay, so that's how we can create our world. And if you want to, at this point, you can go ahead and start creating like walls and whatever. I'm going to leave it just open just so we can see our movement, but I will put just a few marker things. So I'll put like one there, maybe one here, maybe one here, just so we can see what's happening as we move around. Okay, so that's enough of that for now. Now I will make our player. So to make our player, since this is a grid-based movement, we don't really need a character body, but what we will need is an area 3D so that we can detect when we're getting hit by an enemy. So I'm just going to make that the root of our node. So I'll make this an area 3D. And I'll name that player. And what we need here is a collision shape. So I will add a collision shape. And I'm just going to make this a box. And I'll make this, so 2.5 by, let's see, 2.5 by 2.5. Okay, so it's just going to be a cube, just a little bit smaller than our actual world. So I'm going to put this in its own folder called player. Okay, now, when we look at this from above, so if I just click on the Y, this is straight down. We can see that we have our Z-axis and our X-axis, and our editor camera is looking straight down at this along the Y-axis. And the first thing that we need to talk about for making the player script is how movement works. So if we look at our player, we can see that it inherits from Node 3D, which has a transform. Now, this has in code, we can refer to the global transform or the local transform. For right now, it doesn't really matter because in this player scene, the global transform is the local transform. They're the same, but when we add our player to the playground, they will be different. So a couple things here. So if we move in the positive Z direction, that will be this way because there's this arrow here. This arrow shows us the positive direction of that axis. So if we were to move like 3, which would be like 1 grid step, it'll go that way. And if we move in the positive X-axis, it'll go to the right. So I'm going to undo that. Now, so this is pretty straightforward. If we're going to do grid-based movement, what we're going to have to do is go 3 steps at a time because our grid is 3 by 3. So like if we look straight down at this, this is a 3 by 3 tile. So if we were standing here, we would want to move here. Or if we were standing here, we might want to move there and then there and then there. So it's a 3-unit step in any one direction. So that will be how far we go. Now for rotation, which is another thing we'll be able to do, so we're going to rotate around the y-axis, which is this axis we're looking at right here. Now in math, when we go rotation from here to here, this is a positive rotation, and we're going to be using radians to specify the rotation, not degrees, although right here it's in degrees. So if we add 90 degrees, or pi over 2, what will happen is if our player is facing into the negative z direction, which is the default for like straight ahead, if we were to add pi over 2, then we would rotate to here. Or if we add 90 degrees, it'll rotate from here to here. So let's watch that. So I'm going to just click on this and just drag it to the right. And you can see if we get to 90, there, it's facing now to the left. So if we undo that, then if I were to drag it down, it'll rotate to the right. Okay. So we're always, So we're kind of always thinking about which direction am I facing and how do I want to rotate when I turn. But we also need to think about what direction is in front of me. So let's talk about this mathematically really quick. So if we've got our axis, like this, and if this is x and this is z, and then if we've got our player over here, if we say go forward, well, without knowing which way our player's facing, go forward is kind of meaningless. But if we say, what is the direction you're currently facing? We can say, oh, it's this way. So then what does go forward mean? Well, what go forward means is take a step to the positive x direction. So go 3 in the x direction, if we were to say go forward. But if we were to say, if this is the way we're facing, and we say take a step backward, then we would want to go this way. So there's a function in Godot for asking, well, what direction is forward that you are facing? And that is, so that is global transform dot basis dot z. So basis. Oh, it's dot z for what's forward, and then dot x is left and right. So even though this is the z direction for the world, your basis dot z is what's relative to you, the player. So we're going to use that when we write this script. Okay, so we're going to start with just a very basic script. So I'm going to create this player script. Hopefully that it went in player. Yes, it did. Okay, so what we're going to need, well, I guess first of all, let's go into our project settings. We'll go move forward, move backward, right, move left, turn left, and turn right. Now, so in classic keyboard fashion, I'm going to make these W, S, A, and D. And then for this game, I'm going to have turn left be Q and turn right be E. All right. So now we're going to have our const step size equals 3.0. So that's our step. Then we'll have const speed, move speed, and we can make this, I don't know, 0.3. Then we can have const turn speed, 0.4, something like that. We're not going to worry about these constants too much yet. We'll do that in a minute. But I'm going to jump down here, and I'm going to go func physics process. I don't think we're going to need delta quite yet, so I'll underscore it. Now, what I'm going to do is I'm going to define functions for each of these different things. So for now, I'm going to say if input.isActionJustPressed move forward, then I'll do move forward. But we haven't defined that yet, so I'm going to just define it down here. So func move forward. I'm just going to define all of these right here really quick. Okay, so we're going to have move forward. We're going to have move backward, left, move right, turn left, and turn right. Okay. So in move forward, all we're going to have to do is just say, we first have to ask, where are we? Like, which direction are we facing? So we're going to say, so we're just going to move position plus equal, or position plus equals position global position dot basis dot z, or wait, position equals plus step size. I think we do global position. Or no, global transform. Let's see. So I think this is expecting a vector 3. This is, so we want to do times step size. There. Okay. So this is our vector 3 global position. This is our relative position. Let's see. And I think we need to do globe. Yeah, we need to do plus equals. Oh, and actually we want to do, for forward, we need to do minus equals, because forward is in the negative z direction. So then for backward, we would want to do the same thing, but we want to do positive. So plus. For move left, we would do plus equals x. And then for move right, do minus equals x. Now for turn left, we do, let's see, global rotation. For turn left, we need to do plus equals pi over 2.0. And then for turn right, we do global rotation minus equals pi over 2.0. Okay. Oh, dot y. Dot y. Okay. So, in theory, this should work. So let's just test this out. So let's instantiate our player. And are we? Oh, and we can't really see it. Let's see. And then I'm gonna put us just down in, let's see, 5. Oh, right, we're over here. Wait, 7 point. That's right. What if we do 10? Yeah, I want us to start in this bottom corner. So 10.5. Okay. So now if we run our scene, select the current in material, we'll just put it out here. Did it save it? Okay. Select current. There. And we didn't add a camera. That's the other thing we need. Okay, camera 3D. All right, so by default, our camera will be facing in the negative Z direction, which is what we want. All right. Okay, so now if I push forward, we are moving on the grid and nothing else is happening. It's odd. Did I not save the script? Okay, well, move forward works. Oh, because we didn't add these functions, so um, now you might be wondering, well, why do we have these functions when all it does is just call this thing for one line of code? Well, we're going to be changing this, and it's going to make this a whole lot easier to deal with, especially because if you have played a game like Eye of the Beholder, you know we don't just have keyboard inputs, we also have user interface inputs. So what we're going to do is map those UI elements to these functions as well. So it's going to make all of this a lot cleaner and easier to deal with. So let's just test this again. Okay, so I have my left and right backwards, but at least forward and backwards is working. And turning is working, and let's see, right and left is just flipped. So, oh, move left is negative, move right is positive. There. Okay, so now if I move to the right and I move to the left, now the issue is, well, I can move through walls because we're not using any sort of collision. So let's deal with that. And we're just going to kind of deal with issues one at a time as they come up and as we encounter them. So the way I'm going to deal with this is if I flip back over here, I'm just going to use some ray casts. So I'm going to add a ray cast 3D. And I'm going to say this is the forward ray. And then I'll hit Control D to duplicate that. And I'll do backward ray. Left ray. And right ray. And all of these are just going in the same direction right now. What I'm going to do is for our forward ray, I'm going to say we can collide with areas and bodies. Yeah, I'm going to enable both of those. And then where does this go? It's not straight down. I want the forward ray to go minus 1.5. Or actually, yeah, 1.5. Okay, so now if we look at this, we should be able to see it extends just beyond the bounds of this box. So it will be able to touch like something right in front of us. And actually, I think I want to make this minus 2. Does it matter? Yeah, we'll make it 2. All right, backward ray, we'll make this 2. And left ray, we want this to be minus 2. Right ray, make this 0 and 2. All right, so now if we look straight from above, we can see these rays sticking out where we want them to be. And now in our script, what we can say, we can take each of these, drag them into our scene, or into our code. So now we've got references to each of them. So if not is, so in our forward ray, we want to look forward ray dot is colliding. Then we can do that. And if not backward ray dot is colliding. That. And if not a dot is colliding. Okay. So now, if we move up into this wall, I can't move into it. And if I move to the left, if I move down, now I can no longer move through these things, but I can otherwise move around the scene. So good. That's exactly what we want. But what I like to do is, rather than just strict grid movement where it's like you just kind of teleport from one spot to another, I think it looks a little cleaner and more modern to have you sort of like interpolate your position. So rather than just like jump, 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 what we can do is have an interpolation of the step. So, and the other thing about this, can't really see it right now since we are just instantly teleporting, but we're going to want it to be such that during that interpolation, you can't move like right now we're on a strict grid. We don't want it to be where if I'm halfway through a movement and get another movement input, that I then get a new target position. So I'm going to do a couple things. So I'm going to go var is moving bool equals false. And then down here, I'm going to say if not is thing. I'll do all this stuff. Then what I will do is I'm going to create a target position variable. So I'm going to say target position vector 3. And I'm going to create a ready function and say target position equals global position. So that way we can just have this target position that's set by these things. So I will go in our physics process. If we're not moving, then we can detect input. Otherwise, we want to move towards that target position. So I'll go else. Then if not global position equals target position, I'll say global position equals lerp global position target position. And I'll say move speed, which we set earlier. So I set that to 0.3. And what I'm going to do down here is instead I'm going to say target position, and instead of minus equals, it's going to be equals global position minus that. And then the same thing here. So it'll be target position equals global position plus that. This will be target global transform. This will be the same thing, but it'll be plus. So then the one more thing we need to do, so hopefully this makes sense. So we're setting a target position based on where we are versus minus where we want to be or plus where we want to be. And then, so this is our direction times our step size. And then if we're not there yet, then we do this. And then we can say if global position dot distance to target position less than 0.1, and we'll say global position equals target position and is moving equals false. Then the other thing we have to do is say is moving equals true. Do that in all of these. Leave it out of rotation for now just so we can test this. So now we get more of like a, it actually looks like we're moving until we get to where we want to be. Now rotation is still instant, so we'll do that next. But this is working pretty well. Okay. So let's do the same thing with rotation. So we'll say, we're going to do this a little bit different. So I'm going to have so func on rotation ended void is moving equals false. We need this because we're going to need a tween that rotates us, and then when that tween is done, it's going to emit the tween finished signal, which we're going to connect to on rotation ended. So what we're going to do is we're going to say target rotation. So we need our target rotation of, and we'll say target rotation equals rotation.y plus pi over 2. We'll say target rotation equals global rotation.y minus pi over 2. Then for both of these, we'll do basically the same thing. We're going to do var tween equals create tween tween property, do self rotation y target rotation and turn speed. Then we'll do tween.finished connect. We'll do on rotation ended, take out that. Then you can do the same thing down here. So we can see what we're doing here. We've got our target rotation. We set it to this plus or minus pi over 2. And then we create a tween, and the tween will move in between where we are and where we want to be. And so it'll go tween property, and then it'll do on itself. Let's see, so like what object? And it's going to tween ourself. It's our rotation y. It's going to move towards target rotation at turn speed. So we now turn. It's a little bit slow. Let's change that to 0.3. That's pretty good. And if I'm in the middle of moving, I can't rotate, and if I'm in the middle of rotating, I can't turn. Maybe... looks like I kind of can, actually. That shouldn't be able to happen. But so yeah, for some reason it's not locking in there. So we'll try to figure that out. But in any case, we've got our movement done now. So for now, that's kind of all we need to do for player movement. So now what we need is our user interface. So in order to do this, right now we have a camera that's right inside of our player, and that is fine. But if we want a UI where we can have like stuff off to the side, like on Eye of the Beholder, where we can see player characters and their hands and that sort of thing, what we need is a sub viewport. So I'm going to create a sub viewport container. And this is going to be in our 2D renderer, it's going to be a UI. And I'm just going to make it like about right there, maybe, and make this part of that same size. Now what we need is a sub viewport, and we need to put our camera there as a child of sub viewport. Okay, now the issue is, if we run this, if we move around, our character, even though you can't really see it, our character is moving around, but the camera is not. So if I were to, let's see, debug visible collision shapes, you should be able to see, let's see, where is our guy? Their camera facing. Oh, it's outside, that's right. So rather than do that, what we will do is we're going to create our func process. Just going to say camera. Oh, we need our reference to our camera. I'm just going to call it camera, not camera 3D. Camera dot global basis equals and global basis. Oh, camera dot global transform equals global transform. That's what it is. Okay. So this blue line out here, that's the ray that we're casting to the north, and so that's colliding. Let's turn these visible collision shapes off. Okay, so this isn't sized correctly, so let's go into our 2D. We can see that this sub viewport, well, first of all, let's go project settings, general, go to window. Let's make this bigger. Okay. All right, now that's bigger. Sub viewport. Yeah, that looks good. Now this, if we look here, just make this an even 1500. See where it is. So 1450. Then that down here, you can see that that's 749. Just make it 1750. So now if we run, see we've got a lot bigger area to view, which is good. Okay. I actually want our rotation speed to be just a little bit higher. Oh, 2. So we don't want to wait forever to be able to turn. Yeah, that looks a lot better. Okay. So the next thing we want in our player, in our UI, we want to be able to see a compass. Now, for now, I'm not going to do like a full like graphical compass, but I can do that in another episode. But what we'll do is we'll put the compass and then we'll put some buttons here. So I'm going to add a child node and a grid container. And this is going to be our direction buttons. Where is that right now? Right now it's way up here. Whoops. I'm going to go. Their parent. Oh, let's go. Put it down here. There. There. Actually, grid container like this. Okay. I'm actually going to do. I think this will be fine, but I'm going to do canvas layer. That child of that. All right. I'm going to put this right below, maybe just a few pixels down. And actually what I can do is do add child node. I'll do a horizontal HBox container. That up. Then have this be a child of that. So that, oh, there it didn't. All right, I'm going to go down here. Go like right there. So then this can inherit. I'm going to do, let's see, we want 3 columns because we want to be able to go turn left, forward, turn right, left, down, right. So that's 6 buttons. So I'm going to go add a button. So this will be turn left button. We'll say turn left. And duplicate that. And we'll say forward. Duplicate for turn right. Turn right button. Turn right. Duplicate, and we'll go left button, back button, right button. Say left, backward. Right. Okay. Now since we have all of this, we could center that, but I'll leave it for now. Just going to add a label. Say this is our compass. Say north. All right. So now we're going to use the button's pressed signals. Say pressed, I'm going to connect to pick. So this is turn left, so we're just going to connect that to turn left. Go connect. Forward, pressed, pick, move forward. This is why having those functions makes this super fast and easy. Pressed, pick, turn right, connect, left, pressed, pick, move left, back, whoops, pressed, pick, backward, connect, right, pressed, pick, right. All right. Now let's just visually check and make sure each of these has something connected to it. It does. So now let's run the game. Whoops. Global. Looking at here. Oh, we need canvas layer. That. Okay. There. Okay, so now if I just don't use the keyboard, I can use these buttons to move around, just like I did with the keyboard before. Or I can use the keyboard still and do all that. All right, now I'm really bothered by why this isn't working. Oh. Oh, because, okay. So I have to say it's moving equals true. Moving is true. All right. Whoop. Okay, so this is one little thing that can happen because of the way we're doing rotations. I think what we want to do is just do rotation, not global rotation. Yeah, so now we can rotate forever and it's fine. And we do all this. Oops. Still run into that issue. It's that. So it's moving. To do it up here, maybe. Okay, now that looks good. Okay, now what we need to change our compass. And it, so really quick, so what I changed here is just moved this is moving true up to the very top. So I think that's all I needed to do because I think it was not registering since it was following tween finished, or this tween, but I'm not entirely sure, but that seems to have fixed it. So Now what we want to do is we need a way to update our compass. So right now, we just have a compass label. What I'm going to add is a func update compass, and I'm going to have turn direction be a string. Wait. Okay, so if turn direction equals right, we'll do pass aleph turn direction left, do something else. So if we are facing north, that means if compass label equals north, then when we turn to the right, compass label equals east. If compass label equals east, then we turn to the south, so compass label equals south. If compass label equals south, compass label equals west, and then we can say else compass label equals north. So if we're facing north, we turn to the east. If we're facing east, we turn to the south. If we're facing south, we turn to the west. Otherwise, we are facing west, so we turn north. So now I'm just going to copy all of this, but we're going the other way. So if compass label equals north, then we go west. If it's east, then we go north. If it's south, then we go east. So if it's north, we go west. If it's east, we go north. If it's south, we go east. Northeast, south. So west, north, east. So we go south. So north we go west, east we go north, south we go east. Otherwise, if it's west, we go south. Okay, so now we also need to call that function. So you're going to need to go update compass right, whoops, left, and then turn right, update compass right. Okay. What happened here? Object and string. Object and string. Oh, whoops. Don't need. Been doing too much programming in other languages. That's not it. Function. Label. Take compass. Oh, that text. Yeah. So compass label is the actual label. What we need is a reference to the label text. So if we look in the inspector, it's the text. Oops. Okay. Now I'll try this again. There we go. Okay, so we're facing north. We go east, south, west, north. North, west, south, east. Good. That's exactly what we want. Okay. So the one last thing we can do is go back into 2D, and if we want one more container, we can make this our character container. We'll just give it 2 columns, anchor it to the right, and we'll just drag this over here, drag it down. This is that there. And we can actually make this go all the way down. This will be where we put our characters, and we won't actually like do anything with this today, other than like let's see, we want texture rectangle, and we'll add in our little dude. Go duplicate. We run it. There, we've got our 4 characters. So we'll do more with this in a future video, do more with this in a future video, but hopefully you can see how you can create, you know, your own game and your own level. From here, if we wanted to actually make this into more of a level, go into our grid map, and we can erase these, and then we can make this a little more interesting. So we could start with like a little hallway, and then we can go over here. We could make a room up here. We can make another hallway over here, and make this come down, or just whatever you want. So, oh, and I haven't put a ceiling on this yet. Let's do that. So let's go add a, so I'm going to call this our ground. Then let's actually just duplicate it and say ceiling. But I'm going to clear this. I'm going to add in our brick material, and then I'm going to turn on 3D snapping. Come right up there. Oh, right, there is one more thing I want to do. Let's see. Do we have to flip this over? Yeah. Swarm rotation, say 180. There. Okay. So our sun is coming through, which isn't quite right. So what I'm going to do, just run this again. Yeah, so our sun is coming through, which isn't really what we want. So let's take the sun out. And then in our player, I will add in an omni light. And let's see. The one we want, I think it's the omni. Let's see. On this. Now it's a little too bright in here. It doesn't quite look like a cave. It looks more like like way too much light is bleeding through. So let's go to playground, open up this world environment. Energy, let's say like sky. Sky's fine. Okay, now if we run this, now it looks a lot more like what we want. Okay, so that was the last part. Okay, so next time we'll work on fixing up some of this stuff and being able to interact with the world. Maybe we'll add in some doors and some buttons and levers, stuff to trigger the doors. But if you made it this far, congratulations. This is a lot of work. So I hope this was useful. If you do have any questions or comments or things you would find useful for the series, please do let me know in a comment. Otherwise, we will see you in the next one.